I'm here to solve this Skyscrapers puzzle from Murat. It has a few 2's in the grid, which will drive some of the solve, but really these consecutive series are what get us started. As with a lot of Skyscrapers puzzles, the largest digits, which force the largest buildings to be pretty far away, are a place to start. The 6 in this row has to be in the 5th or 6th cell. The 6 in this column has to be in the 5th or 6th cell, but we see it's not possible down here. So I'll mark this 6, and with just 5 total cells, this has to be a strictly increasing series. And so when it's a situation like this, I like marking that straight away. The next thing that you can do is really consider in different positions how the limits of the smallest or largest sizes of buildings are there. And I won't often write this in, but there's a kind of constraint at the start of these puzzles that as you get one further cell away from a 5, the first digit has to be 1 or 2. If it's any larger than that, if it's a 3, 4, 5, or 6, it's going to be hiding the 1 and 2 buildings at least, and you can't get up to 5 total buildings. 5 means you have to see at least one of the 2 smallest buildings. That 1 cell away, you have to see buildings at least as small as 3. You can't see a building of size 4 or 5 here, so forth going on. And a different parallel version of the same thing can be written actually up in this corner, that a 3 coming down can't see a building larger than a 4, and a 4 coming down can't see a building larger than 3. But it sets up a constraint we talked about in another video this week, but is always true with 2 clues, which is that 2 clues see the immediate cell that's in front of them and the largest building. And in the case that a 5 isn't in front, in this case where 6 is the largest number, where a 5 isn't in front of the 2, the 5 has to be behind the next big digit. And so the way we're going to really drive the solve is to think about what that constraint means. And right now it at least means that a 6 is in one of these 3 cells and a 5 is in one of these 3 cells. But looking at this 2 constraint, a 5 can't be in this top rows. So we have something like this, which is the 5 is here and the 6 is here. Looking across this space, the 5 still has to sit somewhere, but it has to be behind a 6, and neither of these, this cell is another 1, 2, 3, 4 cell. So this is 6, this is 5. We're going to get that actually the first digit has to be the largest possible of 4 to make the whole space work. The thing I see that I haven't done yet is actually think about where the largest digits work for these columns. And this 3 can't have a 6 in this cell, or this cell, the 6 would block this clue, and this would be too close. So in this column, the options are these 2 cells, and a 4 has to be at least 4 away, so the options are these 2 cells. And when I already have this clue in the grid, this is giving the same information. Both of these columns take 6s in the 4th or 6th rows, and so that forces this nice constraint here. Next thing I see is that this last 2 clue still needs some help. Actually, both of these 2 clues can be looked at right now. The 4 needs to be filled in this column and has to be as close to the 2 as possible, so that there are still some hidden buildings. This 2 has to have a building larger than a 3 or 4 in its first space. At the first moment we written 3, 4 here, we could have written 4, 5 here, but because we've actually placed the 4 above, it's now strictly possible to place it like so. We've got the remaining digits now coming in. Let's sort of look at some of them. This 5 needs to see another 5, which has to be in one of these spots. There's a case where this 5 is coming down like that, and looks like any of these cells right now in this column can take the 5. We do have to keep this strictly ascending, so where this is 1, 2, this cell can be cleaned up to be 2, 3. And we can actually think about the 6 here. We didn't mark this in yet. Where can the 4 go in this space? And it can't go in this cell. It's got to come at least up to here. You'll actually notice that in this column, the 4 is also forced into one of these 2 cells, and so we have strictly placed 4 of the 4s in clues or in exact position. So the remaining 2 4s are known in 2 of these cells, either these cells or those cells. And the thing to see is if a 4 goes here with our 5 node in the grid, and one reason I like using these nodes is you get instant information. I see a 2, 3 building, I see a 4, I see a 5, I see 6, that's too many. So the 4's gotta be up here, the 4's there. That fills the space a little better. Now we have to think through what looks to be the last 5. This row doesn't have spots for 5s except for here, so these clues are now fulfilled. You get something like these as the 2 cells that 5s will go in. Here, if the 4 comes down, 5, 6, 4, 5, 6 all seen plus this building, that's no good. So again, the 4 comes up, 4 comes here. When the 5 is here, sorry, when a 4 is here, the 5 goes there. 4, 5, 4, 5, 6. We'll do a little bit of cleanup just for the sake of the video. Like competition, I wouldn't do this. Now we have a 4 that sees 4 cells, and they're the ones that are left blank plus the 6, and so that's just a strictly increasing series. So that goes in quickly. Leaves behind 1, 2, 1, 2 for this row. These now actually form a pair, so we know exactly that that's 1, 2 space. This 1 forces this to be a 2, which now makes all these come up. This 5 seeing enough buildings makes this be 2, 3 coming up. Now back to just Latin square steps to finish it out. Got this 1, which is a 2, 1, is a 3, 2, and a closing 3. So not the hardest skyscraper in the world. It was a Saturday puzzle, but what it really took was a few kinds of steps. First, knowing to handle 2s in the right way, where you will always hide the second largest building behind the largest building. So the 6, 5 deductions here and here come from really understanding 2 clues well. And then the rest come from just note taking and option limiting, and where we got 2 6s here, eventually 2 5s here, 2 4s here. Those all lead to considerations of a position like this, where the 5 is in one of these cells, but a 4 can't go here when we are considering this box of where the 2 4s go. And so some of the notation I was using here to just track sort of how buildings of certain sizes enter the grid is useful to eventually decide on the final solution and the final steering of those clues. So hope you learn a little bit about solving this puzzle, and we'll see you again soon.